Okie dokie. Avery is at the 0.96, running at a speed of 10 units per hour, right? Units per hour, which means that if he were running directly along the grid lines, he could cover 10 spaces every hour. He's running towards the line, 4x plus 3y equals 24. And the question is, how long will it take him to get there? So we got to figure out, well, if we know his speed, we just have to figure out how far it is in order to figure out how long it's going to take him to get there. So we have to find the distance from the 0.96 down to the line. We've done this before. We just have to, distance means perpendicular distance, so we're going to have to find the equation of a line that is perpendicular to 4x plus 3y equals 24, perpendicular to that, and then find out where that line intersects with the original line, and then how far is the distance from that point of intersection to that point. So first, I'm not going to rewrite this in slope-intercept form. So 3y equals negative 4x plus 24, divide by 3 on both sides, and I get negative 4/3 x plus 8. Tells you my slope for this line is negative 4/3. So the slope for my other line needs to be, negative reciprocal of that, is positive 3/4. So that's like going down 3 over 1, 2, 3, 4, down 3 over 1, 2, 3, 4. I'm going to connect that with a line here. I always like to, it's not necessary, I guess, to actually draw this out, but I like to because once I find my point of intersection, it'll be handy to look at the graph and tell, does that seem about right or not? Okay, so the equation for this line is going to be y equals mx minus h plus k, where m is the slope, and hk is the point that the line goes through. We got the slope, we got the line. Y equals 3/4 x minus 9 plus 6. So let's put this into slope-intercept form. We have y equals 3/4 x minus 27/4. So let's see, clear 27/4, and then we got to add 6 plus 6 is 12 3/4, which is 51/4. So 51/4, okay? So now we have our two equations. Now we'll take the mx plus b portion of each equation, set them equal to each other, and then solve for x. So we've got 3/4 x minus 51/4 equals negative 4/3 x plus 8. So let's see, I'll add 4/3 x to each side. 3abc4 plus 4abc3 gives us 2 1/12, which is 25/12. So I got 25/12 x equals, I'm going to add 51/4 to each side. So I have 8 plus 51/4, which is 20 3/4, or 83/4. And then we'll just divide by 25/12 on each side. So divide by 25/12. 9 24/25. 9 24, 249/25. 249/25. Oh, what an ugly number. But it's, uh-oh. See, here's why I'm glad I graphed this, because look, 9 24/25 is clearly not the x-coordinate here. 1, 2, 3, 4. It's going to be a little bit more than 4. So I'm going to pause and go back and find my mistake. Oh, now I found it. See over here, negative 51/4. That's like a number that's a little bit bigger than 12. For the y-intercept for this line, which is clearly going to cross somewhere right around here, something's wrong with that number right there. So I'll go back and redo this calculation. 3/4 times negative 9. Oops. 3/4 times negative 9, and then plus 6 is negative 3/4, which seems a little more reasonable. So that should be negative 3/4, which makes this negative 3/4, which makes this, let's see, 8 plus 3/4 is going to be, well, 8 3/4, or 35/4. This is 35/4, and we're going to divide that by 25/12. Divided by 25/12 gives us 4 1/5, which is more like what we expected, or 21/5. See, sketching it out paid off. I caught that mistake. 21/5. So now we got to go plug that back into one of the two equations. So y equals, I'll pick this one up here, 21/5 plus 8. I'm just going to punch all that into my calculator. So I already got the 21/5 in there. So times negative 4/3 plus 8 gives us 2 2/5. All right, so that's 2 2/5, which is 12/5. Let's go check, see if that makes sense. So 1, 2, and 2/5. Yeah, that makes sense. So our point here is 21/5. That's our point of intersection. Now we got to find the distance from here down to here. So distance equals 9 minus 21/5 squared plus 6 minus 12/5 squared, and I'm just going to punch all this into the calculator, make it easy. 9 minus 21/5 squared plus 6 minus 12/5 squared gives us, oh, really? 36. Huh. 36, which is 6 units, really? 1, 2, 3, 4, 1, 2, 3, 4. Oh, okay. Wasn't expecting that. 6 units exactly. What a deal. And then at 10 units per hour, so we know his rate, we know the distance, and we know that rate times time equals distance, which means that time is distance over rate. So time equals 6 units divided by 10 units per hour, and so time equals 0.6 hours. Okay. So again, overall, what we had to do here is just we got the point, we got the line, we have to find the distance of the line in order to figure out how much time it's going to take him at this given speed. So we had to write the equation for the perpendicular line, remembering that the slope for the new line will be the negative reciprocal of the old line. And then once we have the two equations, we set the mx plus b portions of them equal to each other. We solve for x. That gives us the x coordinate for our point of intersection. We plug that back into one of the two equations. We get our y coordinate for the point of intersection. Once we have the, one second, bud. Once we have the x and y coordinates for that point of intersection, we just plug them into the distance formula in order to find the distance between our original point and our point of intersection. And once we have that distance, then we just plug it into that rate time distance formula to find the time.